Hello, you're welcome to Master Sima class. And in this live class, we want to consider this topic, which is circle geometry. Okay? In our previous live class, we have looked at this topic and we started by looking at the definition of a circle, and also we looked at some theorems, or let me say some lemma. So when we have something called lemma. Lemma means those things that comes with theorem. And then we discover that a circle can form angle at the center. That is, a chord can form angle at the center. And in this case, when this chord, we have chord AB here, this chord can form this angle at the center here. And we have two angles there at the center now. That is, we have the one inside here, we call it obtuse angle. And we have the one outside here, we call it a reflex angle. Okay, so that is that. And also the second lemma here, we have that a chord also, or an arc. Let's use an arc in this case now. You might say this is A, this is B. So this is arc AB. So if we draw a line that join A to B now, it becomes a chord. Now this arc also can subtend angle at the circumference at the upper part here. If this is C, it can also subtend an angle at the other side here. This is B, this is D here. So we have two angles at the circumference as well. So we should understand this. That's okay, let's join it and make it a chord. A chord can subtend two angles at the center of a circle, and also can subtend two angles at the circumference of a circle. And then we draw the theorem from that. And what the theorem 1 is saying, we have theorem 1. And for theorem 1, what we have there is that the angle subtended at the center by a chord or an arc is twice that angle which is obtained at circumference. That is, for theorem 1, we have this in the diagram. If this is center of the circle O, and we have a chord, we call it chord AB now, the angle formed, the word subtended, we can say is synonymous to the word formed. So when we say subtended, we are referring to as formed. So the angle subtended at the center by this chord is twice the angle subtended at the circumference. So let's say this angle at the center here. The corresponding angle to that at the circumference is this angle here. So if this angle at the circumference is x, we have angle at the center now to be 2x. So this theorem is like the foundation of all the theorems under the circle geometry. So there is need for us to really understand this theorem. That is, the angle at the center is bigger 2 times than the angle at circumference. Okay, so the opposite is also true for this. The same thing we have center of the circle O, and we have a chord. Let's say this is AB, and we have this angle at the center. You know, we talk about two angles at the center. For the first case here, we look at this angle inside, which is the obtuse angle. Now, for the second case here, we look at this angle outside, which is the reflex angle. Okay? And the angle at circumference that is corresponding to this angle here will be at this other side. So that's very important for us to be able to differentiate. So which angle, if this angle is at the center, which angle will be at the circumference corresponding to it? It will be on which side? You know, we have two segments here now, the bigger one and the smaller one. So for the reflex angle, okay, the angle will be at the other side here, right? So this angle is at the circumference now. So let's call this angle as y. That's angle at the circumference. The angle at center here will now be 2y. That's theorem 1. The angle at center is twice the angle at circumference. Okay? Then theorem 2 follows this theorem. And what this theorem 2 is talking about is that we have all the angles obtained by a chord or an arc in a segment of a circle are all equal. Now let's look at this in diagram. If this is a circle with center O here, and we have this as a chord, and we call this as chord AB, and what this theorem says is that all the angles obtained by this chord in one segment. Here we have two segments now, the minor and the major. Now we can form so many angles here by this chord. This is one, this is another one, this is another one, this is another one here. So here we have four angles now at this circumference, like 1, 2, 3, 4, formed by this. All the angles are coming from this chord AB. So which means that all these angles here now are equal. Why? It follows theorem 1. Like when we join A to the center now, A to O, and also join B to O, this is angle at center. And all this angle here is at the circumference. And they are all corresponding to this angle at center. So that if this is X, angle at circumference, this is also 2x, angle at center. And if this is 2x, since this is angle at circumference as well, this is x. This angle at the center, this angle at circumference, this is x. This angle at center, this angle at circumference, this is x. So which makes these angles here to be all equal. So that is why we have angle in the same segment are all equal. Okay. Then, in the same way, we have theorem 3. Let's call this theorem 3 now. And for theorem 3, we have that angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. When we have a circle with center O, a line that is drawn from that center to touch the circumference of both sides, that line is called a diameter. We have this line AB here is a diameter. It divides this circle into two. We have two parts now, which are semicircles. So the angle formed by this diameter is 90 degrees. So this angle formed here is 90 degrees at the circumference. And this also follows from the theorem 1 that says the angle at the center is twice the angle at the circumference. Okay, now you already know that here, this is a straight line at the center. And the angle at the center here, angle on the straight line, that's 180 degrees. So if the angle at the center here is 180 degrees, and it is twice the one at the circumference, it means we divide this by 2. So 180 degrees divided by 2, that's 90. That's why angle at circumference here is 90 degrees. So that's theorem 3. So this theorem 1, 2, 3, a question, or let me say a rider. A rider is a problem combined together. When we solve problem on circle geometry, in a single question, you might make use of the theorem 1, theorem 2, and theorem 3. So the ability to recognize all these theorems is very important and be able to work with it. Okay. So now we also have theorem 4. We have theorem 4. We have theorem 5. We have theorem 6, theorem 7, theorem 8, theorem 9. And this, from theorem 7 to 8, we categorize it under tangent theorem. Tangent theorem. So, when we get there, we see what is meant by a tangent theorem. Okay, now, for the purpose of this theorem that we looked at, we can solve some problem on this to demonstrate the theorem 1, 2, and 3 that we have looked at. Okay? So, let's look at some of the likely question here. Okay, this question is just a simple one on the theorem 1. That is, let's look at this as like some examples in this class. Then, the first question we have here, we have a circle, and this is center of the circle O. And this, we have these two lines, which are radius. This angle at the center here has 80 degrees. This here, we are given this angle as circumference as 5x. And the question says find x. Now, here, the application of the first theorem, that's theorem 1. And we have angle at the center, that's 80. And we know the angle at the center is 2 times angle at circumference. So that is simple thing we need here. So that means we have 80 equals to 2 times 5x. That is, this becomes 80 equals to 2 times 5, that's 10, that's 10x. So to get x now, just divide both sides by 10. Divide this out by 10. Also divide this out by 10. That is, here 10 cancelled each other. We have x now left. It is equals to 80 over 10, that's 8. So x is 8 degrees. So that's simple application of the first theorem. Then also when we look at this as well as the examples, example 1, 2. Okay, the same way where we have this circle, this center O or the circle, and we have this angle at the center, which is reflex here. This is 290 degrees. And we have this angle at the circumference here. This is labeled as P, Q, then R. Okay, and the question says we should find the value of angle QPR. QPR. So using 3 letters to label angles, it means the reference point is the letter at the middle. So moving from Q to P, then from P to R. So this angle is what we are finding. And this angle is angle at the circumference. Okay, and if this angle is angle at the circumference, it means that it should have a corresponding angle at the center. And the angle at the center, which is corresponding to this angle, is the other angle here, That is this obtuse angle. Okay, and not this other one that is given. So there is need for us to get this other angle, and which is obtuse angle. So we can say that here we have obtuse angle QOR will be equals to, because the angle here should be 360 degrees. So that will be 360 degrees minus 290 degrees. That is, this angle now will be 70 degrees. So the angle at center here is 70 degrees. So to get this angle QPR is not difficult again, because we have angle at center is twice the angle at circumference. So we can say that 70 degrees is equals to 2 times angle QPR. This angle at the center is 2 times angle at the circumference. So that's the simple application of the theorem 1. Alright, please help us share this video. Just click a thumbs up, share it so that it will reach more audience. And thank you for joining Master T Math class. Okay. Then here, to get angle QPR, just divide both sides by 2. Divide this side by 2. Also divide this side by 2. Here 2 cancel each other, and we have angle QPR equals to 70 over 2, that's 35 degrees. So which means that the angle at circumference now here is 35 degrees. So that's some of the examples to demonstrate that that theorem, which is first theorem. Okay, so now let's look at another one here. We call this number 3 now. Number 3 examples. The third example is here. We have this angle is given at the center here, that's 126 degrees. Then we are given another angle here this way, and that is PQR. And the question says find angle PQR. PQ, then QR. This angle is what we are finding. And from here, we discover that this is angle at the circumference here, and it should have a corresponding angle at the center. And the angle at the center corresponding to this angle at the circumference is not this 126 degree, but the other one here. So that's the angle at the center. Okay, so that is why we need to get this angle first. Because we are given this, we can get the other one. So we can say the reflex angle POR there will be 360 degrees minus 126 degrees. So we subtract here now. Then here this becomes 4, 3, 2. That's 234 degrees. So this angle here now is 234 degrees. Okay, that is the angle at center here now is twice this angle at circumference, which means we can write it as 234 degrees is equals to 2 times angle PQR, which is at the circumference. So to get this angle now, divide both sides by 2, and this becomes, divide this side by 2, divide this side by 2. Then we have PQR left. This cancels each other. That's angle PQR left equals to 234 over 2 here give us 117 degrees. So this angle is 117 degrees. That is what we have. That's the simple way to apply this particular theorem. Okay, so thank you for watching us here live at Master T Math Class. Okay, now let's look at this as well. It is on the second theorem, and we can label this as example 4. That is here. We have this given. This is just a simple and direct solution applying theorem 2. We have this circle, and here we have a chord with this and this line crossing it. Also, we have a chord here. These join each other. These also join each other. And this angle is giving us 38 degrees. This is giving us 86 degrees. Here we have this angle, okay. All right. So okay, what are we trying to apply here? I think this one, we're trying to see the theorem 2 from this example. Okay, so let's just leave this one like this and leave this one as 38 degrees here. Actually, when you look at this, if you are putting x here, you are putting y here, you're finding the value of x and y. This angle and this angle lies on the same segment. Just like when we draw it out, and we have something like this. That is, you have this angle here and this angle here. So these two angles lies in the same segment by this chord. So whatever this angle is, 86 degrees. So this angle also will be 86 degrees. So which means here that simply x equals to 86 degrees. You can say angles in the same segment. Angle in the same segment are equal. Then same thing here. This is 38 degrees. This also lies in the same segment. When you look at it on the other side, this chord here form two angles. One here and another one here. So whatever this angle is, this angle also will be. So this is 38 degrees. This is y. So we can say y is equals to 38 degrees. So also same reason, angle is same segment. So that is that on the application of the second theory. Okay, now we are live at Master T Math Class, which I believe you are following us and you are enjoying us. So do it to subscribe and stay tuned. By next time we meet, we shall look at from theorem 4. So we look at the application with some examples and also theorem 5, theorem 4 and 5. So do well not to miss this class and subscribe, turn on your notification, share this video as well, and like, put a thumbs up. Thank you. See you next class and bye.